Hello friends. So in today's question, each of three blocks in the figure has a mass of 10 kg. The coefficient of static friction and kinetic friction at each surface of contact between the blocks is static is 0.3 and kinetic is 0.2 respectively. The ground is smooth. Determine the acceleration of each block when the horizontal forces as shown are applied. So there are three blocks A, B and C. On A 25 Newton and on C 15 Newton towards left and B 100 Newton towards right is being applied. So we are going to find out what will be the acceleration for the blocks. So let us say that all blocks are moving together. You say suppose all blocks move together with acceleration A. So we can draw that they are moving together. This is A plus B plus C, and the external force toward this side is 100 Newton and towards left it is 25 and this is our 50 Newton. Okay. So we can write the equation as each mass is given as 10. Okay. So we can say acceleration A will be equal to 100 minus 25 plus 15 divided by 30. 10 plus 10 plus 10. So we can say our acceleration A will be coming as 2 meter per second square. And we are assuming that they are moving in this direction with the acceleration A. Now we find out what will be the frictional force between A and B. Okay. You can say force of friction between A and B. We can simply say this as FRAB, which will be equal to mu A into NA. Okay, let me draw it here. This is our A block and it is moving in this direction with the acceleration A. We have applied force 25 Newton on this side. So this will be our FAB and there will be a normal NA in the upper direction and weight is given at 10, so this will be 10 G. So and NA is equal to 10 G, which is 10 into 10, so we get NA is equal to 100 Newton. And mu A is our given as static, so this is 0.3, so we write 0.3 into 100, this will be giving us 30 Newton. So this is our maximum value of friction, so we can say this is FRAB max, which is equal to FRAB, maximum value of friction between block A and block B. Now let us calculate the actual value of friction between A and B. Okay. You can say the actual value of friction between A and B. In actual value of friction between A and B, we can write this as as they are moving towards you can say right side. So we can say equation is FAB minus 25 is equal to mass is 10 multiplied by A, which is the acceleration. So we get this as 10 into 2, which is equal to over 20, and we find out that our FAB is equal to 20 plus 25, which is equal to 45 newtons. So this is our the value of the friction, the actual value of the friction, but the maximum available is only 30 Newton. So if you compare between the actual value and the maximum available value, you can say that maximum friction between A and B, which is given as FR AB max, is less than the actual value of the friction, less than the actual value of friction, or in simple terms we can say FRAB max is less than FRAB. Friction between A and B. Okay. So based on this condition, we can clearly see, or rather say, that block A is going to slip over block B. Okay. From here we can say slipping is going to happen between block A and block B. Therefore, if slipping is going to happen, the nature of the you can say friction will be now kinetic nature. Okay. With this we can say that friction between A and B will be of kinetic in nature, or we can say mu k will be equal to 0.2. So in this condition we can find out that FRAB will be equal to mu k of A into NA, and we already know mu k is 0.2 and NA is 100. So here we can find out that the friction FR between AB will be coming as 20 Newton. And obviously slipping is going to take place between A and B, so therefore you can also say that acceleration of A will not be equal to that was our 2 meter per second square. Okay, so it means it will be different than this value. So we can say that block A will have different acceleration Let us call this as AA, and we can find out that value of AA will be equal to the applied force is 25, value of the friction is 20, and divided by mass, that is 10. Okay, so we can draw it here like this. This is our block A, and we have a force of 25, friction FRAB to 20, and acceleration is AA. Okay, and we are going to say that it is moving in this direction now, and this value will be coming as 0.5 meter per second square. Okay. You can say that acceleration of A is equal to 0.5 meter per second square. This is the acceleration of block A, and it will be towards left. Now we already concluded. We started with that both are traveling, all the three are traveling with same acceleration, but we now concluded that block A will be having a different acceleration. So now let us assume that both B and C are moving with same acceleration. Okay, so we can say let's consider that block B and block C are moving with same acceleration, which is capital A. Okay, so we say they move with same acceleration, which is capital A, and let us draw it here. So this is now B plus C, and a force is being applied of, this is 100 Newton, and on this side on C it was 15 Newton, and here is a smooth surface, and we say that it is having an acceleration and moving in this direction with the acceleration A. So we can write the value of A will be equal to value of A will be equal to 100 minus, okay, if they are B and C are moving in this direction, I forgot to mention that there is a friction force also, that is FAB, and FAB we already concluded its value is equal to 20 Newton. This will be 20 Newton. So this will become 100 minus 15 plus 20 divided by the weight, that is 10 plus 10, and sorry, this is capital A. Capital A will be coming as 3.25 meter per second square. So this is the acceleration with which B and C will be moving. So if you draw the free body diagram for B and C, okay, so we can draw like this. For block B, we have a applied force of 100 Newton toward this side, and there is friction that is called FC, and here it will be FAB, and we are going to have, this is C block, which is applied force is 15 Newton, and there is friction FC in this direction. So we can find out what will be the value of the friction for block C. So we can say for block C, FC yeah, and it is moving with the acceleration a in this direction. So we can say that Fc minus 15 will be equal to, its mass is given as 10, so this will be 10 multiplied by a, and value of a is 3.25, so this is 10 into 3.25, and from here we can find out that our Fc will be equal to 32.5 plus 15, and which will be coming equal to as 47.5 newtons. Okay. This was the value of the friction which is between B and C. Now let us find out what will be the possible maximum value between block B and C. Maximum value of the friction. We can say maximum possible value of friction between B and C. Let us call that as Fc max. So we have, this is our B block and this is our C block. Okay. And above it, this is our A block. So we can say this Fc max is equal to mu s. We have Ma plus Mb, mass of A plus mass of B is G. Okay. So this will be the value of friction of maximum value of friction between B and C. So this is our Fc, friction between this. So this is mass of A and mass of B. And if you put the values, we get Fc max, mu static is 0.3, and this is 10 plus 10, that is 20 into 10. So we get maximum value of the friction, Fc max, is coming as equal to 60 newtons. Now if you compare the maximum value which we got and the value of the friction, Fc, you can clearly see that Fc max is less than frequency of Fc. So under this condition, both B and C should move together. With an acceleration which is given as capital A, and that is equal to 3.25 meter per second square. So from here we can say that acceleration of B, that is AB, will be equal to AC will be equal to 3.25 meter per second square. So this is the acceleration of B as well as acceleration of C, and the block A will be moving with the acceleration of 0.5, which will be different than both the accelerations. So this completes the question. Thank you.